Hello, welcome everybody. Are you tired? Who's tired? No, are you still awake? Raise your hand if you're still awake. All right, very good, very good. So, thanks for being here. Thanks for holding out. Thanks for still being awake. We're going to talk about ECMAScript 6. And ECMAScript 6 is the next version of JavaScript. The idea is to improve JavaScript and to make it better for all those things that it's used for right now, because it even shows up in robots. So it's insane where it's used in lots of places. Pretty incredible. And for very big apps and lots of stuff. So in this presentation, I'm going to give a quick overview of ES6. Who has already seen a few ECMAScript 6 features of you? All right, that's a lot of people. Okay, I'm guessing like 60%. Then I will give an assessment of ES6 features because there's different opinions on which ones of them are good parts and bad parts. Which ones, some are more controversial than others, and I'm going to talk about that. So I will tell you what to think, basically, but I'll do it in a nice way. I'll be gentle. And I'll conclude with cool stuff that you can do with ECMAScript 6. And you'll see quite a bit of code, so that'll be fun. All right, so I don't see my built-in screen, but that's okay, I think. All right. First, a little bit of background. So, who of you knows the difference between JavaScript and ECMAScript? Because these words are always there. And who knows the difference, what the difference is? So, it's fascinating. Both of them are around, but it's not always quite clear what they mean. And the thing is, the name ECMAScript only exists because there's a trademark on JavaScript. So for the standard, they couldn't use JavaScript, so they created a new name, and they deliberately made it ugly because they thought that that would increase the incentive to change it later on to something nicer. But as so many improvised solutions, ECMAScript has stayed around, and, well, it kind of grows on you, or maybe not, I don't know. So that means that ECMAScript is the official name of the language, and JavaScript is what everybody else calls it. And whenever you see ECMAScript, people are usually talking about versions of JavaScript. And ECMAScript Harmony is a set of features. So ECMAScript Harmony is not ECMAScript 6. It's a superset of ECMAScript 6. It's a kind of a set of features that was scheduled to appear after ES5. And some of the Harmony ideas will extend into ES7 and later. And very recently, there's been a naming change, and kind of very last minute, TC39, the committee that evolves JavaScript in collaboration with experts, they decided to change the name to ECMAScript 2015 in preparation for yearly schedules that start next year. So the official name is not ECMAScript 6 anymore. The official name is now ECMAScript 2015. But everybody who writes about ECMAScript, everybody who uses ECMAScript, continues to call it ES6, because that's just what it's been called for such a long time. That's what everybody is familiar with. So here we're going a bit against, or most people are going a bit against TC39. I will start using the years starting in 2016, because ES7 is the first yearly and relatively small release. So quick timetable, the spec is frozen, everything is done. In June 2015, ES6 will become an official standard, and features are continually appearing in engines. And so this what you see. This link here is to a table by Kangax, and there you can see what features are already available in browsers. And I think feature completeness, you'll have that by the end of the year in most engines, that they'll have all of the features, maybe early next year. But thanks to transpilation, that is not too much of a problem. So you can use them. Who of you have heard of Babel? All right, so that is a solution that lets you transpile or compile JavaScript to ES6 to ES5. I think with a few tricks also to ES3. And that way you can already use ES6 right now, and it's awesome. Code is so much nicer, so much more compact. And it works really, really well. So the solution I'm using at the moment, and there are others that people are very happy with, the solution I'm using at the moment is Webpack plus Babel plus Gulp. And that gives you a very convenient workflow. So let's start with handing out advice. And before I can, I have to give you a quick look at classes. Classes are not that radical a departure from what we already have. So mainly when it comes to single classes, there are mainly just nice syntax for what we already have. So it's not that exciting a feature, and people who say we don't need classes are actually partly right, because we got along fine without them. On the other hand, classes get nicer once you have subclassing. And if you create a subclass of another class, classes are very convenient. And they have a few other advantages and objective ones, in my opinion. So is it still objective if it's in my opinion? I'm not sure. Yeah, okay. But those are really important advantages. So so one thing is they make code more portable. And at the moment, it's really annoying because sometimes you have a piece of code from one framework and you just can't move it to another framework because every framework has its own inheritance library, and that's just madness. So it'll be nice to finally have something that is used by all of the frameworks out there. And this process is already starting because React has moved from, or is in the process of moving from their own inheritance library to ES6 classes. So when you write a React component, you can now optionally use ES6 classes, and that is awesome. And the second advantage is tool support. That's a big one, because beforehand, there were so many ways of doing inheritance that to now have something that's canonical will allow IDEs and type checkers and many tools to work much better because they know what to expect. And previously, you could kind of say, well, this is my own inheritance framework, and this is, and you could annotate in comments, and I extend my own class A and so on. And then some of the IDEs out there, such as WebStorm, I think that kind of would work. But this is nicer because now we have a standard. And long-term classes will be a foundation for many more features, some of which are really important. So traits is something traits and mixins are loosely similar. They bring a very nice way of multiple inheritance without some of the trickiness associated with multiple inheritance. Will bring that to JavaScript. And then you have like pieces of classes, and you can assemble the pieces, and reusing class fragments will be nice. And it's for many problems, it's just for object-oriented design. It's a really cool solution and much more versatile than single inheritance that classes give you. So that will be nice. You'll get value objects, so in a way you'll be able to define new primitives that are compared by content and not by identity, as objects are. You'll get immutable objects probably, so there'll be probably a way to say that this class produces immutable instances. And there even now a proposal is being written for possibly later adding immutable data structures to JavaScript as well. So that'll be cool. Subclassing built-ins is nice. That's something that classes enable as well, because some of the internal stuff in constructors so far prevented you from subclassing errors and from subclassing arrays. And classes will make that possible. And finally, it'll be easy to write one's own error class that you can throw when you want to throw an exception. And this is something that should not be underestimated. Some people thumb their noses a bit at the newcomers who love their stupid classes. But if you're coming from another language and you're already very suspicious of JavaScript, and some people really passionately hate it before they tried it, and I think even while they use it, and if you make it easier for those people, that matters too. And they can get started. They'll be a bit ignorant about the internals, but with classes, being unaware of the internals is not that much of a problem, in my opinion. So you can get very far. You can get more confident in most of the language, and then later, once you've used it a lot, you can read up on the details. And you won't be overwhelmed with everything at the same time. So there's more of a gradual process of learning the language. So, but there are also some cons. I initially opposed classes because their syntax is quite different from their semantics. So if you look at the way they're looking, they look like an object literal. And they're really not. They're a function. So they're being translated to a function under the hood. And if you do type of a class, it's a function. And that's really kind of strange. So it's not ideal, but it's good enough. And backwards compatibility with current code matters. So all in all, I'm relatively happy with classes. And I think it's a lot better to have them than not to have them. So that's not a glowing endorsement, but I really think they're good enough, and you should use them. I will too, and I am too. All right. So then we have the good and the boring. This is stuff that you can already have right now, but what ES6 adds. So you have the polyfillable parts, and you can add that via a library, and there are good libraries out there. But thanks to ES6, it'll be a standard. It'll be common in code. You'll see something like that in code. You will know what it means, and it'll make everybody's lives easier. But that's not exciting. I mean, that's something we could have already if we wanted to. Kind of same for modules and classes, because we have good module systems. Problem is we have two of them. We have CommonJS and AMD. And having that is unfortunate, and ES6 modules will mean that there's going to be a single standard, and it will, and then there'll be a single ecosystem for modules, and that'll be great. So unify the community that is currently a bit fragmented. Same thing with classes, as I already explained. And arrow functions are will let you write, because there's lots of callbacks in JavaScript. With arrow functions, that is much more compact, which is cool. And it's convenience, but it's not something that we don't have yet. And it'll help newcomers because they won't have to worry about this. And this is always a bit difficult to talk about this. So you can air quote or air, I don't know, or air backtick. All right. So there's more good, and then we get to the good, new, and exciting features. So we have generators, which basically bring cooperative multitasking to JavaScript, and that is something that is sorely needed, because whenever you do asynchronous programming, what you do is you make a call and you want to block. You are in a process and you want to go to sleep and wake up once the result is back. And generators will lay the foundation or are a way to make that happen in JavaScript right now, and you'll see an example. Proxies will bring metaprogramming, so there'll be more stuff that you can do with libraries. WeakMaps let you bring a new way of handling private data. How that works, we'll see in a moment. And then there's Destructuring, and I'll show what that can do too. So, and then there are the OK features that are, well, kind of not terribly exciting, but symbols are overall a win. The initial plan was that they were going to be used for private data as well, for private properties. That didn't pan out. So now they just make sure that properties don't clash. That you can, if you have a library and you want to make a method special, you then have to be extra cerebral about the name of the method. If you use a symbol, your invented name will never clash with any other method. And that is something that has hampered the evolution of JavaScript, that you weren't able to do that because there were always naming conflicts, and there still are. And some of the names in ES7 will be changed because there are clashes with existing software that's out there. So, various cool features. Let's look at Destructuring. So what Destructuring lets you do is, if you use a pattern on the left-hand side of an assignment, you can easily extract stuff from the right-hand side. And it can be used in variable declarations. Whenever you declare a variable, the first value it gets can be extracted. So here, I'm declaring two variables. I'm declaring the variable f, and I'm declaring the variable l. You can use them in assignments, in parameter definitions, and that'll allow you to do some very, very cool stuff that we'll see later on, and in the for-of loop. So for arrays, this is an example. Here you get x becomes the first array element, y becomes the second array element. These are newly declared variables. Then you can also swap. So this is an assignment, and you swap. X gets the value of y, y gets the value of x. And this is, this method down here returns an array, and thanks to Destructuring, you directly can access the elements of that array, the year, so this is the first group in the regular expression, the month, the second group in the regular expression, and the day, the third group. And you don't have to create an intermediate array and access the indices. So that's nice. All right, and now this is really, really cool. Who has used this style of providing parameters to functions already? So this is cool. So I'm guessing maybe 30, 40%. So this is nice because every parameter gets a label. And if you were to read 20 and 3 in a function call, then you'd be wondering, well, but what do these mean? I mean, it could be, or it gets even worse if they're like 4 numbers or more. And here, if you select entries, you don't have to look at the documentation. You can directly read the source code and find out what everything is about. And the other thing is, optional parameters are much easier because you can't just omit start or end or both. So it's a really nice style of programming. I think it's used in parts of jQuery. It's becoming more and more a more and more prominent style of coding in this way. But then what all functions become are basically functions that have a single parameter that is an object. But to extract the data is a bit cumbersome because then you have to check, is there an object at all, or are there no parameters, as in the last one here? And then you have to assign each of the options, default values, and so on. And with Destructuring, this is how compact it becomes. So this is the default value. This is a syntax that is very similar to, the pattern syntax is very similar to an object literal. And you can omit, you don't have to say step, step, if both are the same. If the key and the value are the same name, then you can omit the key. So this is another abbreviation that's possible in ES6. So it becomes very compact. And if you look at that code, ES6 is not introducing a new feature, but they still make it possible to handle name parameters as opposed to positional parameters that we all use now in a way that looks as if it was built in. And long-term engines could, or probably will, even be able to recognize that this pattern is being used, and then there will be no intermediate object. Because you see immediately that this 20 has to go into this parameter. And there's no need, because everything is fairly static here, there's no need to produce the intermediate object. And it's great because there was no need to introduce a new feature, and we could just, and it was possible to just use destructuring. Then you get template literals, which are nice too. So finally we have string interpolation that many other languages have, so we can just put in the middle something in the middle of it, and it's much more readable. And also you can write string literals with multiple lines, which is cool too. Yeah, I like it. Enthusiasm, very good. So the WeakMaps are another new feature that, for example, Java already has. And with WeakMaps, you can use arbitrary keys and arbitrary values. But the advantage is that whenever the key is garbage collected, the whole entry is removed. So using objects as keys does not prevent the objects from being garbage collected, and no memory will leak. And that's an interesting sound. And thus they're very convenient for attaching data to objects, because you can say object 1 maps to some data, and when the object disappears, the whole entry is removed and nothing stays around. So you can externally attach stuff to objects and don't have to modify them. And for private data, right now, if you want to be 100% safe with private data, you will save it as local variables in the constructor. So that's the closure pattern that Crockford really made popular. Who of you have used that pattern? All right. I'm ambivalent about it because it's very safe. And if you do that, if you put stuff into local variables in the constructor, it's very safe. And you can be absolutely sure that no one outside can access the data. So it's really and truly private. On the other hand, code becomes less convenient because everything that can access the private data has to be added to the object inside the constructor. So for my own code, I usually use prefix names with underscore for private data, which is not as pure, but makes the code slightly more elegant. So with WeakMaps, you have an additional way that kind of combines the best of both worlds. And it looks a bit weird at first, but you'll get used to it, and then it's actually kind of fun. So what you do is you create one WeakMap per private property. And then you associate each instance with the private data. And once the instance goes away, if there's one instance in here that needs a counter, once that instance goes away, the data, its private data in counter will be removed. So garbage collection is still possible. And this is what the code looks like. So this is an ES6 class, a countdown. This is the constructor where everything is set up. And this is the data that is passed into the class that should remain private within the class. And what we do is we map the current instance to the private data and store it in the WeakMap. So it's very weird, but also kind of cool. And probably it's cool because it's weird. So the second line, there we do it again for the second one of the two pieces of private data. And so this is how we store some private data, and this is how we get the counter back later on here. So generators. So generators are basically pausable functions. So what we do here is, this is almost like a normal function. It has an asterisk here. So we, and these two things, those are new. The yield is like a return that also pauses. So once we get to the yield, or in this case, it's a pausing mechanism. So and you can see how that works here. So you call the constructor, it gives you back a so-called generator object. And that object is now a remote controller for this function. And initially this function is paused. Then I call next. Then I proceed. So initially the function is paused before the start. So if there's a line 0, that's where the function is paused. Then I say next, the function wakes up and is like, okay, let's get to work. It does some work, it prints the started, and then it says yield, oh, now I'll go to sleep again. Then you get back from the next. Then the next thing you do is you're now here and you send something to this position in the function. And when you do that, the function wakes up again, gets a value back, and then logs it. So now you get output. And the object underneath you can ignore, because now we're ignoring the output that generators make. We're only interested in the input that they receive. And so on. So with the B next, you send something to this position, wakes up again, and so on. And a way to use that's very cool is with processing asynchronous data. And what I'm doing here, you can kind of ignore the specifics. I'm starting with this function, and that pushes, that's a normal function, and that normal function pushes data into these generators. So you start with a file name that's read, then the file is read in chunks, and the chunks are split into lines. The lines are prefixed by numbers, and then we print the lines. And how that happens is this. So how that works is like this. So you have a file name and a target. You use this Node.js function, create read stream. And here you have an event listener, because the function works asynchronously. So the function doesn't come back with a result. It occasionally says, oh, I got new data, new block of data, new block of data. And these are like click events. So like registering a click handler for a button. This is similar. And this event from the read stream, it says, yeah, new data, deal with it. And then you have a buffer. I convert the buffer to a string, and I push this block of data, which may contain multiple new lines and whatever. It's an arbitrary block of text, an arbitrary fragment of the file. I deal with that by pushing it into the next generator. And then afterwards, I have to close the generator that it knows it's over. That's important for handling, but that's more of a detail. And now, split lines is the handler who receives blocks of data and wants to partition that into lines. And what it does, and this is very, very cool, this is a while loop. This is synchronous code. And within this while loop, it receives asynchronous data. And because it pauses and is woken up whenever a new piece of data arrives, we get to use a while loop. And this looks scary. It's like an infinite loop. Isn't this going to block? But due to yield falling asleep and waking up only when the next block of text, the next arbitrary sequence of characters comes in, due to that, we get to use a loop. We get to use a loop where previously we needed to register a callback, an event handler. And what I do down here, the previous is where I accumulate what was previously there. And every new data block gets added, gets appended to it. And as soon as I discover a new line, so here whenever I find a new line, I push one line to the next generator, to the target, the next part of the chain of generators. So now I found a new line in here, and I say, yeah, I found a whole line of text. And I can push that line of text to the next generator. And if the end of the file is reached, then I have to say, okay, I don't care about the new line, pass on whatever I received, because there may not be a final new line. And so this is the next element in the chain of generators. And that one is a for loop, if you can believe it. So here it receives the lines from the previous generators, and it just produces another line and passes it on to the next generator. With a line, it prefixes a line number. Again, this is a for loop. This is synchronous code for something that trickles in asynchronously. And the awesome thing is that the line numbering and the printing of the lines at the very end starts as soon as the data arrives. So usually you wait for all of the data, you split it in lines, but here's block by block. As soon as a line is ready, it gets printed. Because we do everything on demand via the generators. And this is the last generator. Again, a loop, really, really cool. It pauses and wakes up whenever a new line arrives and just logs the line. Chunk by chunk, just on demand. So, what are the takeaways when it comes to ECMAScript 6? Many features are already in engines. The nice thing is, if you transpile, you can already use it today, and it's so nice. Very often on Twitter, you now read tweets that say, all right, I finally tried out ES6 and I couldn't believe how much fun it was, especially with arrow functions, and many of the tiny pieces just interconnect really, really well. And the biggest impact on the community is, I think we'll have classes and modules, because they unify the community that is now quite fragmented. And they will make all of our lives easier, even though they're kind of boring. Thank you. Don't let the rhino bite you. So I'm in the process of finishing a book on ES6, and that will be available online for free. So that is, and the link is embedded here. It's called Exploring ES6, and if you do a web search for it now, you should already find it. Do we still have time for questions? Otherwise, you can just come to me offline. We do have, all right. Mics, are they taken care of? All right, they are? All right. Cool. Ask away.
Don't you think that some parts of ECMAScript 6 will have negative impact on code readability?
What are your specific worries?
Okay, for example, destructuring is not really clear for me.
Oh yeah. Two things. It will, and even with some of the literals you've seen with the backticks and the $sign and interpolation, I noticed that now when I look at the examples, it's a bit, it takes getting used to. So, but once you use it more often, your eyes will get used to, and just imagine, like, JavaScript looks very weird to other people, and to you, like, So it will take some getting used to. And whenever I write my code, I always do, in the later passes, I always try to make it easier to read. So even now, you can even use like the ternary operator or some existing features to make your JavaScript almost impossible to read. So with destructuring, and I fully agree, you have to be extra careful that it really does make sense.
Okay, thank you.
Yeah.
Okay, so usually when there are two competing standards and someone comes up and says, I know, I'll make a new standard that will unify them, then the result is that there are three standards. Yeah. Aren't you afraid this will happen?
At the moment, things look fairly good that ES6 modules will actually become a common standard. And kind of a problem is right now that we don't have a native implementation in browsers yet. But what I do when I write my code with Babel and Webpack, I can write all my own modules with ES6 syntax and just use NPM and CommonJS for external libraries. So then once we have native modules in the browsers, you won't have to rewrite. And there's also ways now that transpilers, so that I've recently seen a recommendation, and I agree with it, that if you were to create a new library right now, you would probably write the module in ES6 and transpile it to AMD and to CommonJS. So I think it will succeed. There's broad support for it. Not everybody is completely happy with it. But it's just too compelling, and the way the syntax is designed is mostly as a mix of AMD and CommonJS. So it works asynchronously, like AMD, and the syntax is designed for asynchronicity. CommonJS has not been designed for asynchronicity, but the syntax is also as compact as CommonJS and less verbose than AMD, which is for browsers and asynchronous. All right, next question.
Do you hear me?
I do hear you, but possibly not the others. But I can also...
Raz, dva.
Yeah.
Okay, one question. I know that the let keyword is used to create variables with the block level scope. But I don't see any var keyword. Is it a common use case to completely skip the var?
Yes. Yeah. So in ES6 there are the problem is if you want to evolve a web language, all the existing code has to still run. So you can't remove anything. You can only add new stuff. And two new ways of declaring variables that they have added in ES6 they're called let and const. And there for a while there was a slogan out there that was let is the new var. So what I'm doing right now is for mutable data, including objects, I'm using let. And for constant data, so frozen objects or primitives, I'm using const. And it's very convenient because but var, if you use it responsibly and if your functions aren't too big, so you should have relatively small functions anyway, then I already prefer, like some schools of thought, they tell you have to put the var at the very beginning of the function. But then you have a problem if the variable that is declared by var is used way down, and you want to stay local with your fragment of code. You don't want it to be like out there, declared out there. So I occasionally, if I know that this is a fragment of code that I maybe eventually want to move somewhere else, or that I want to understand in isolation, I already pretend that var is block scoped. And usually that's not dangerous. So you have to be a bit more careful. And with let, you don't have to be careful anymore. And that's the beauty of it. And the nice thing is that Babel compiles let and const to a simple var, so you don't even pay a performance penalty for using it right now in transpiled ES6 code, and that is very nice. You look familiar.
How about debugging transpiled code? If you,
Oh yeah.
Does it have support for source maps, or
Yes,
how do you handle that?
Babel has support for source maps. So for you, who of you have heard of source maps? Wow, I'm impressed. So that's, I'm guessing 70, 80%. So the source maps are nice that whenever you compile from another language to JavaScript, you can tell a JavaScript engine, especially in browsers, what lines of the original code map to the compiled code. So I think CoffeeScript must have been one of the first languages that supported that. So for every, if you compiled CoffeeScript to JavaScript, for every line there was a mapping rule in a so-called source map that tells the engine, okay, line 1 of CoffeeScript maps to lines 6 to 8 of JavaScript. And then you can actually, in the debugger, debug the original file. So you step through the lines of the original file while actually running the compiled code. And that's a pretty solid illusion for, and it will be even more important in the future because more and more stuff will get compiled to JavaScript. So it'll be pretty nice. And now they're even compiling C++ to JavaScript and getting 70% of the native performance, which is incredible. And then source maps will help again because you can debug C++ while you run JavaScript. All right. Any more questions? Okay, one more question.
Yep. As we know, for now, ES6 transforms to ES5. So have you ever met any issues with memory leaks using ES6? And what were or are these issues, and how did you cope with that?
So far, it's not been a problem. So because the transpilation is obviously you have to be careful if you transpile. But Babel compiles to code that is very similar to handwritten code. So and that makes it very nice. So you can look at the code that Babel generates and you'll be fine. You won't be uncomfortable if you look at it. So I don't, and in the long-term future, memory-wise, ES6 is going to be, has another really cool feature that is tail call optimization. If the last thing you do in a function is a function call, you can, the call stack won't be used. And then you can have almost practically infinite loops without using up the stack space. And that's for some ways of functional programming, or you can, that's really convenient. So if you're a functional programmer or want to use a functional programming style in JavaScript, that's a way that ES6 wastes less memory than ES5.
Thanks.
I think I've seen a hand, or maybe someone was just stretching, I don't know. Oh yeah, this is a hand. Pretty sure.
Hey, WeakMaps and their impact on the memory. Any issues on that?
Yeah.
Or thoughts?
So the WeakMaps are a feature that is practically impossible to polyfill. But there's a trick. And so once engines support it, there won't be any leaks. That's a cool thing about WeakMaps. There's a way to polyfill them if you And they do that if you map a key A to a value B, they store the value B in the key A. And then the key A won't be prevented from being garbage collected, but there is you have a slight problem. There's a tiny bit of a memory leak because the value is stored in the key. But as a workaround, it's pretty clever, and I think for most applications, it's not too bad. And you get much of the functionality of them. But long term, you need support from the engines, and then it'll be a really cool feature to have without leaks.
Yeah. I have a question about generators. Are
Yes.
there any major differences between native generators and the transpiled ones?
Oh, yes. So when generators first appeared, everybody thought this kind of pausing thing that it would be, well, maybe not everybody, but most people, certainly I thought, well, okay, that's it. We have to wait until engines support it natively. And then Facebook came up with a tool that's called Regenerator, and that is used by Babel. So if you use Babel, you're using Regenerator automatically. And what Regenerator does, which is pretty fascinating, it moves the code around and then stores a state internally and has, I think it's like a huge switch statement. And whenever you enter the function again, it says, okay, what state am I currently in? And then it says, okay, you're in step 3, and then case 3, and then step 3 is executed. So it's a huge switch statement. And I think the technique is called trampolining. And it rearranges the code. It even rearranges the loops, and it's very, very clever. It's the code kind of melts your brain when you look at it. But because generators are very flat, that means that this kind of incredible rearranging of the code, that works. And, pardon me? I think so, yeah. So it's, well, of course, you have, like, with the switch statement and everything and keeping the state, you do have a slight problem because, well, you have to switch. But apart from that, it's still a pretty performant solution, pretty fast solution, and pretty faithful as well.
Do you think that something bad has been introduced in ES6, or it's all nice and beautiful? There is something I should avoid, or not?
Yeah. So we had did we have the ugly? I think we had an ugly slide. There was an template destructuring. Okay. Yeah. So this is. Oh, did I skipped that one, didn't I? Yes. All right. Because time was getting short. It must have happened. It wasn't a conscious decision. So the several parts I'm not too fond of. So. I already mentioned the disconnect between the class syntax and the class semantics. So my preference would have been to not have that, but as I said, I think having classes is better than not having them, a lot better. And the workaround is to treat them at face value, to pretend or to buy into the solution. So in the matrix, what was it? Was it the blue pill, or which one was the one where you just stay in the matrix? You get good food and you'll be treated well and it'll be okay. And you'll kill your friends, but it doesn't matter. So the coercion rules for symbols are a bit not as nice, and enumerability is getting worse than ever. But these are tiny things. And obviously, it's still a big language. There'll be a few rough edges. But overall, given how many parties participated, I'm really, really happy with ES6. Thanks for asking. Oh my God, yeah, what happened? I was going to be honest.
So do you have any other hidden slides you would like to reveal now?
I could show more about generators, but I think everybody's tired, aren't they? So there's one other thing that generators... Do you want me to, or is... I can easily... But maybe you need to pack up. So it's up to you, really. I don't want to...
I think it's up to the audience.
Okay. It'll be brief. I won't be long. So the thing is, generators can also be used as data producers. And whenever you have, who has written this kind of a tree? Who has implemented one themselves? Hands up. All right. So the problem, if you create this kind of a tree, it has a root A, it has the children B and C, and the child B has the children C and D. And what you want is, you want to have something simple in order to iterate over all the values. And right now, that is something you can't even do with arrays. You don't even have a simple, well, you have for each as a method. But you don't have a built-in loop that works nicely for arrays. And what ES6 will have is a way for a tree to implement a method that lets you find out about the insides. And with iterators, that is very nice, because if you think about having such a tree, and if you do it via recursion, you call a function, you work with the root. Then from the root, you say, okay, for each of the children, do something again. That is very easy. Probably every one of you has done that in the DOM, right? So you had a loop and said, for every one of the top level on the Fritz. And if you work over a tree, you've said, okay, I'm at the root node, then I do a loop over the children and over the children's children and so on. So if you do recursive function calls, that works nicely. But if you imagine that you have to with a for loop, you have to, whenever the for loop asks you for the next element, you have to give it the next element. And so if you're familiar with iterators in other programming languages, this is what's going on here. And this kind of iterator that we've implemented here, that is very simple because we're using generators. And we're just recursing, and then we're returning the current value and we pause. And whenever the for loop asks us for the next value, we wake up again and say, okay, I'm now here within the loop, give the current child. And then you just, you use this pausing to produce one node at a time. So for iterators, it's very convenient. And one last feature is when it comes to asynchronous programming, you usually have callbacks, and you have to wait for something. And then you have the callback hell and stuff that nests. Oh my God, you can't see it. All right, let's pack it up. You can take a look at the code examples. They should be self-explanatory. Come up to me if you have more questions. It's been fun.